Number one, select or check all statements that are true. So here we're looking at whether a number is rational or irrational. Not only do you have to decide if it's rational or irrational, but you also have to determine if the reason they give you is correct. So, quick review. Rational numbers are decimals that end or repeat, fractions. So remember, a rational number is a number that can be written as a fraction. And the square root of perfect squares. Okay, so irrational So our irrational numbers are decimals that don't end and have no pattern. Okay, can't be a fraction. Square root of imperfect numbers and pi. Okay, so let's take a look at what we have for our options. So the first place to look is, let's focus on this explanation here. Since it is a ratio of two integers, 10 over 15 is rational. Okay, a ratio of two integers is basically saying fraction. So since this is a fraction, it is rational. Well, fractions are rational, so yes, this is correct. Actually, let me put a check mark. Yes. Okay, let's look at number 2 and let's go the opposite kind of order of dealing with this. Because some of you may look and go, well, I'd rather just decide if this answer is right and then go back to the explanation, which is fine. So 11.4 is irrational. Well, 11.4 is a decimal, and that decimal has ended. Irrational means a decimal that doesn't end and that has no pattern. Okay, this decimal ends. So this is not an option. 11.4 is rational. A rational number has a decimal that ends. This is incorrect. So square root of 6 is rational. Well, I have a square root, so now we're looking at these two. Square root of a perfect square is rational. Is 6 a perfect square? No, 6 is not a perfect square, which makes it irrational. Square root of 6 is not irrational. Okay, let's look at the next one and we can look at it from the front side. Since 64 is a perfect square, which is true, so 64 is a perfect square, square root of 64 is rational. Well, perfect squares are rational. That is correct. Since it is an integer, 2 is irrational. Okay. So you don't see integers on any of my lists. And the reason is because anytime you have an integer like the number 2, can I write an integer as a fraction? Yeah. That gets covered under the fraction section. I mean, you could add it, but I'm trying to limit the amount of things you have written. An integer can be written as a fraction, so it's automatically rational. This is incorrect. Integers, whole numbers, negative numbers, they all can be written as fractions, so they are rational. And then none of these are true. That's false because I do have some true. So there's a lot going on here. You're going to have to really know the difference between rational and irrational numbers. Now, the nice thing is number 2 is the same type of situation, but there isn't all the explanations happening. You just literally decide rational or irrational. So, negative square root of 19. Now, if we have a square root, I need it to be perfect. Okay, so for it, this number has to be a perfect square. Is 19 a perfect square? Nope. Since it's not a perfect square, it's irrational. Actually, let me fill this in a little bit better here. Okay. 7.91 repeating. Now, if we have a decimal that repeats, if the decimal repeats, it is rational. Okay, decimals that end and repeat, or end or repeat, are always rational. So because of that little guy right there. Okay, pi. Anything with pi, a number plus pi, a number times pi, a number over pi. The minute pi is involved, it's irrational. Pi makes everything automatically irrational. Next up, another square root. This number inside is perfect. If I have a perfect square, it's automatically rational. The negative makes no difference. Okay, a negative sign does not determine rational or irrational at all. And the last one, I have a fraction. Because it's a fraction, it's automatically rational. Numbers that can be written as fractions are always rational. Okay, you'll have another one. Number 3 is the same type of question. So let's go to number 4. Find 2 consecutive whole numbers that square root of 86 lie between. So this is where I'm looking for a perfect square below and a perfect square above. You're going to need to know your perfect squares, at least up to 100. If you do, you know that 81 is below and 100 is above. Now the directions look for whole number. I want whole numbers. These are not whole numbers. These are I need to find the perfect squares that are above and below, because if I can find the perfect squares, then I can square root and get my whole numbers. Square root of 86 is between 9 and 10. So get your perfect squares that are above and below, square root them to get your answer. Five is the same. So for number 6, number 6 says, plot square root of 55 on the decimal number line as accurately as possible. Note that you can use a calculator to help you find the answer. Okay. So because they give you a calculator, you don't need to do anything crazy. Let's start with the calculator. Okay, square root of 55. Now to put this in the calculator, we want to click this square root button right here. 55 equals. We'll round to the nearest hundredth just because I don't feel like trying to find that big, huge number on the number line. We get 7.42 if we round. Okay. Now I have my 7 and I have my 8 on my number line, and I have to figure out where in between this decimal lies. If you remember anything about number lines, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 spaces, which means I have 7.1, 7.2, 0.3, 7.4. So each of these tick marks is another tenth. 1/10, 2/10, 3/10, 4/10, 5/10, and so on. Okay, so if I'm looking for where 7.42 will be, let me get my point. Well, this is 7.4 and this is 7.5. Let me get my pen back. If this is 7.4 and this is 7.5, 7.45 would be about the middle. So I'm going to have to kind of break this down and find where it lies here, okay? Because if I take my point and I plop it in the middle, that's in between 7.4 and 7.5. I need 7.42, okay? On a number line, it would go 7.41, 7.42, and it just counts up, right? So 7.42 is really close to 7.41, which is really close to 7.4. It's not even halfway. It's not close to halfway. So you got to take, this point needs to be like almost at the beginning for me to be correct. Be very careful with this one. You've got to think this one through. It can be very easy or it can be difficult. Okay, I believe 7 and 8 are the same type of question, but let's double check. Yep, same type of question. So 6, 7, and 8 are all the same. Let's head over to 9. Put these numbers in order. So order the numbers from least to greatest, and I do have a calculator. Okay. So we will start with 100 negative 120 over 11. So I have 120 over 11. Now I'm going to round to the hundredths place just to be sure. So my first one is 10.91. Okay. Next one, oops, square root of 113. Again, I'm going to round to the hundredths place. And don't forget, sorry, these are negatives. Negative 10.63. Okay, and the next, we have 10 and 7/10, which I don't even need a calculator for. 10 and 7/10, 10.7, and it's positive. And then my last one, I don't have to do a thing to because it's negative 10.7 repeating. So the first thing that I notice is that all are negative except 10 and 7/10. 10 and 7/10 is the only positive number, so it's obviously going to be the biggest. Now, remembering a number line, let's do a quick review because this is going to mess people up. I look at 0 and I count back to the left on my number line. The further I get away from 0, the larger these digits actually get. The numbers get smaller, but the digits get bigger. So when I'm comparing my numbers up here, if I were to write them in order, negative 10.9, 0.9 is further from 0 than 0.7. Oops. It's actually not this one. It's this one. So 0.9 is further away than 0.7. So if I were writing these on a number line, negative 10.91 would be the furthest away. Negative 10.7 would be the next. And negative 10.63 would be the next. Because remember, the larger the digits, the smaller the number. So negative 10.63 would be next, and that is square root of negative 11, square root of 113. Negative 10.7 repeating would be next. And then 120. Negative 120 over 11 would be the smallest. Be very careful with these negatives. You're going to have negatives on here. I believe 10 is the same. Number 11. Solve v squared equals 25, where v is a real number. Simplify as much as possible. Well, this should be a nice review. I don't want v squared, I want v. So I need to square root each side. Remember, if there is more than one solution, separate them with commas. Okay, sometimes problems want you to have more than one answer, and this is actually the case. You do know that the square root of 25 is 5. We know that. But I also have negative 5 as an answer because negative 5 times negative 5 does equal positive 25. So in this kind of case where they say if there's more than one solution, that's a clue to you that you need to make sure that you are including all the possibilities. So you'll use this box to list 5 and negative 5. Number 12 is the same. Let's go to 13. A square has a perimeter of 40 yards. What is the length of each side? A couple ways you can approach this. Some people are visual and you want to see it. Perimeter. Perimeter is all sides added. So side plus side plus side plus side. All sides are equal because it's a square. So all sides are equal. So it's like 4s, right? S plus S plus S plus S. S added 4 times is 4 times S. So the perimeter is 40 yards. So S plus S plus S plus S has to equal 40. Well, 4S equals 40. What must S equal? 10. So the length of each side would have to be 10 for all 4 to add up to 40. For the next one, still a square, has an area, that's length times width, right? Area is 64 feet squared. So if I have a square, the area is 64. Now the length and the width are both the same measurement, right? So I can just call it side times side. Has to equal 64. Side squared equals 64. Side equals 8. When you're finding the perimeter, we divide by 4 if it's a square because all 4 sides are equal and we're supposed to add those up for perimeter. Area of a square is a side times a side. When you multiply a number by itself, to undo that, you square root it. Or you could have really looked at this part right here and said, what times itself equals 64? And you get 8. Up here, you could have said, well, I have to add the same number 4 times to get 40. Okay, it's 10. You don't have to get fancy with all this extra work, but if you look, everything does flow using, what you've learned already. Next up is 15. cube roots. Okay, so we haven't done a whole lot with cube roots. So what we're going to do is the first thing with the cube root. You really don't have these memorized. So you're going to have to revert back to factor trees, if you remember factor trees. So we're going to complete a factor tree, but now with square roots. So basically I'm looking for two numbers that multiply to make 216. Well, it's even, so I know a 2 is a factor. 2 times what equals 216? Well, 108. Okay, so 2 times 108 equals 216. Now I'm going to continue doing this until I have all prime numbers here. So 2 times 54. 2 times 27. Now it's not even anymore, so I have to say 9 times 3. Square root of 3, square root of 3. So I'm going to continue until I have all prime numbers. Okay, make that look like a 3. Okay. So now what I'm looking for here, because I want the cube root, I'm looking for triples. Okay, x times x times x is x to the third power, right? So I'm looking for triples. I need something times itself times itself. Well, I have that here. Square root of 2 times square root of 2 times, these are cube roots, sorry. So cube root of 2 times cube root of 2 times cube root of 2 actually equals 2. When you square root a squared number, they undo each other. When you cube root a cubed number, they undo each other. Then I have a set of 3s, square cube root of 3 times cube root of 3 times cube root of 3. Actually equals 3. So what I have is 2 times 3 equals 6. Now, on a side note, there's no reason that you can't go back. I think it's maybe number 7. No reason you can't go back to the calculator. There's a cube root on the calculator. Check myself, and 6 is the answer. Just saying. All right, let's look at 17. Solve y to the third power equals 64. Simplify your answer. If there's more than one solution, separate them with commas. So to undo a cube root, to undo a cube, we find the cube root. Something times itself equals 64. Now we can go through the factor tree and say 2 times 32, 8 times 4. And I can look for triples. There's one set, and there's 2 sets. If I have a set of triples, that becomes 2. This set of triples becomes 2. 2 times 2 equals 4. That's one option. Here's the second option. With small numbers, to be honest, you can go through and test out a couple. 2 times 2 times 2 is 8. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 4 times 4 is 16. 16 times 4 is 64. So you could go through the first few and you would find an answer pretty quickly. Or you can go back and grab a calculator. Answer is 8. Oh, it's not. I'm sorry, it's 4. 4 times 4 times 4 equals 64. Answer is 4. Now, there isn't more than one. It is not 4 and negative 4. Because negative 4 times negative 4 times negative 4, would actually equal negative 64. So don't get caught on this one. Be careful.